SpaceX just filed this paperwork, right now with the FCC, for a mission that's never been attempted before. Flight 14, the first attempt to catch a Starship coming home from orbit, and the ship that's going to try it already has a name, Ship 41. It's sitting in the bay right now with both aft flaps installed, getting ready for cryo testing. One vehicle, one catch attempt, months of production data on the line. If this works, Starship stops being a rocket that flies once and gets thrown away. If it fails, the whole timeline slips. Here's everything we know before it happens, built on public FCC filings and Starbase production reporting. Let's start with what actually happened this week. Not a rumor, not a leak, a federal filing. SpaceX submitted an FCC application for Flight 14. And buried inside that filing is one detail that changes everything. It's not labeled as another suborbital test. It's labeled as an orbital return mission. That single word, return, is the whole story. Here's why that matters. Every Starship that has ever flown, every single one, has ended its mission in the ocean. On purpose. Splashdown, then nothing. The booster comes back to the tower. The ship does not. That's been the rule since day one. Flight 14 breaks that rule. For the first time, a Starship is being prepped to come home. Not to a splash zone, to the tower. To the same mechanical arms that have already caught a super heavy booster. Only this time, those arms are reaching for something much harder to catch. And the ship assigned to attempt it already has a name. Ship 41. Let's be clear about how big this is by tracing the timeline that got us here. SpaceX flew 11 test missions of Starship before anyone attempted a booster catch. 11 flights of trial, failure, partial success, before the chopsticks closed around a returning Super Heavy for the first time. That single success took years to set up. It required a tower built to survive the exact heat and shockwave of a returning booster. A guidance system precise enough to bring tons of falling steel within centimeters of two mechanical arms, and a margin for error close to zero. Now compare that to what's happening with the ship. The booster catch had 11 flights of preparation behind it. The ship catch, by Shotwell's own public timeline, gets one flight of preparation. Flight 13, one suborbital shakeout flight to validate the Raptor 3 changes, then straight into the real attempt on Flight 14. That's not 11 tries to get comfortable. That's one warm-up lap before the real race. This is the part that should stop you for a second. SpaceX isn't easing into the hardest maneuver in the program. They're sprinting straight at it. Why a booster catch and a ship catch are not the same problem? Now you might be thinking, SpaceX already caught a booster with the chopsticks, multiple times. So what's the big deal with catching a ship too? Here's the comparison that actually explains it. Picture two objects falling back to Earth. One of them, the booster, has already done its job by the time it returns. It's separated early. It's been falling from a lower altitude, lower speed, simpler trajectory. It's basically dropping straight back down to where it started. The ship is a completely different animal. Ship 41 will have gone all the way to orbital velocity. For context, that's the same general speed range any spacecraft needs to reach low Earth orbit, roughly 27,000 kilometers per hour. The kind of speed where re-entry heat routinely climbs past 1,400 degrees Celsius on a heat shield. SpaceX hasn't published exact re-entry figures for Ship 41 specifically, but those are the physics any vehicle at this speed has to survive. It then has to slow down from that speed, glide through the atmosphere using its flaps for control, flip into a vertical landing orientation in the final seconds, and then thread itself between two mechanical arms with almost no margin for error. That's not a landing. That's threading a needle, while the needle is also on fire. So when Shotwell talks about a ship catch attempt on Flight 14, she's not talking about a minor software update to an already solved problem. She's talking about the single hardest maneuver in the entire Starship program. Harder than the booster catch. Harder than orbital refueling. Possibly the hardest reusable rocket maneuver attempted by anyone, ever. Let's break down why, piece by piece, because the difficulty stacks on top of itself. Start with the heat shield. The bottom of Ship 41, the side that faces the atmosphere during re-entry, is covered in ceramic tiles, the same general design SpaceX has used across every prior Starship flight. Each one has to survive temperatures that would melt most metals outright. Lose even a handful of tiles in the wrong spot, and superheated plasma finds its way into the structure underneath. That's not a small malfunction. That's the difference between a vehicle that survives re-entry and one that doesn't. Then there's the flap problem. Ship 41's two aft flaps, the ones it just had installed, are its only means of steering once it's committed to re-entry. No thrusters firing at that point. No engines. Just two control surfaces fighting against a wall of superheated air, trying to keep the vehicle pointed exactly where it needs to be. Then comes the flip. In the final moments before the catch, Ship 41 has to rotate from a horizontal belly-down orientation into a vertical engines-down orientation. This is the same maneuver that's claimed multiple test vehicles in earlier flights. Get the timing wrong, get the angle wrong, and the vehicle either tumbles or comes in too fast to be caught at all. And only after surviving all of that does the actual catch happen. Two mechanical arms, the same chopsticks that caught the booster, have to close around the ship's catch points at the precise moment it arrives, matching its descent speed, absorbing the impact, holding on without crushing the vehicle. Heat shield, flaps, flip, catch. 4 separate failure points, each one capable of ending the mission on its own, all of them happening in sequence, in minutes, with no second chances. The vehicle behind the headline. Ship 41 isn't a brand new, untested prototype rushed onto the pad. It's a vehicle that's been moving through a deliberate sequence of checkpoints. It already has both aft flaps installed, the control surfaces it will rely on to steer itself through re-entry. It's heading to Massey's for cryogenic testing, the proof test that confirms its tanks can hold propellant under pressure without failure. Here's the detail worth sitting with. While Ship 41 prepares for its historic attempt, it's not alone on the production line. Ship 40 already has its engines installed and is closer to flying first on Flight 13. Ship 42 just had its nose cone stacked inside Star Factory, the final step before rollout. That means 3 ships are moving through 3 different stages of readiness at the same time inside the same facility. This is the part that's easy to miss if you only look at headlines. SpaceX isn't building one hero vehicle for one historic flight. It's running a production line where the historic flight is just the next item on a list that keeps refilling itself. Compare that to literally any other heavy lift program in history, the Saturn V, the Space Shuttle, even competing reusable rocket programs today. None of them had 3 vehicles in active production at the same time, each one feeding into the next flight on a monthly cadence. This is a different category of operation, and Ship 41 just happens to be the one in the spotlight right now. But a ship is only as good as what's pushing it. So let's talk about the engines underneath Ship 41, because this is where Flight 13 earns its place as the necessary warm-up before Flight 14 can happen at all. Ship 41 carries 6 Raptor 3 engines, 3 optimized for sea-level operation during ascent, and 3 vacuum-optimized engines for the upper reaches of flight. Raptor 3 isn't just a name change from earlier versions. It's a redesign aimed at cutting weight, simplifying plumbing, and improving the engine's ability to restart reliably in space, which matters enormously for what happens during the catch sequence, when Ship 41 has to relight engines at exactly the right moment to slow itself into the arms of the tower. Here's the logic chain that connects everything we've covered so far. Flight 13 exists specifically to validate these Raptor 3 changes under real flight conditions, using Ship 40 and Booster 20. Only once that data comes back does Flight 14 happen, with Ship 41 and a new booster, Booster 21, built behind it on the same production line. That's the gap SpaceX is closing. Not because they're reckless, but because at some point after every subsystem has been proven independently, the only way to learn whether they all work together is to actually try it. The ground game. Nobody talks about. Here's a question worth asking. What does it actually take to catch something falling at orbital speed? It's not just about the ship being ready. The tower has to be ready too. And that's where Pad 2 comes in. On June 15th, SpaceX ran a full-duration test of the trench deluge system at Pad 2. That's the system that floods the launch area with water to absorb the shock wave and heat from an engine ignition. The reason this test matters isn't the test itself, it's the timing. This was the first time that system had been activated since Flight 12, which means SpaceX wasn't just running a routine check. They were confirming that the infrastructure that survived a previous launch is still structurally sound enough to support the next one. Think about what's riding on that single deluge system test. The SQD arm, the quick disconnect that feeds propellant to the booster. The BQDs, the hold-down clamps that release at exactly the right millisecond. Every one of those systems has to perform a precise, choreographed sequence. At the exact moment, Ship 41 is also performing its own precise, choreographed sequence, hundreds of kilometers away, falling out of the sky. Two complex systems, one ground-based, one airborne. Both have to be perfect at the same second for the catch to work. That's the part of the story that doesn't make it into most headlines. It's not just will the ship land correctly. It's will two completely separate engineering systems, one on the ground and one in freefall, synchronize perfectly on the first real attempt. There's another layer to this worth understanding because it explains why SpaceX is testing the deluge system so deliberately, instead of just assuming it still works. A launch tower isn't a static piece of concrete. Every time a booster lifts off, the engines generate enough heat and acoustic energy to damage the structure underneath it. The deluge system exists specifically to counteract that, flooding the pad with water that absorbs the shockwave and prevents the sound and heat from reflecting back up into the vehicle itself. After Flight 12, that system had gone untested, not because SpaceX forgot about it, but because there was no reason to activate it until the next launch was close enough to need it. Running it now, ahead of Flight 13, is SpaceX confirming a basic but critical fact: that the pad, which survived one launch, can survive another. It sounds almost too simple to matter, but skip that step and you risk a pad failure mid-launch, which would set the entire Flight 13 to Flight 14 timeline back by months, not days. This is the unglamorous side of spaceflight that rarely gets airtime. Nobody makes a highlight reel out of a deluge system test, but without it working perfectly, there is no Flight 13, and without Flight 13, there is no Flight 14. And without Flight 14, Ship 41 never gets its shot at the tower. Notice the chain this builds. The engines got their proving ground on Flight 13. The flaps were already validated on earlier flights. The pad just got recertified through the deluge test. Every single piece of Flight 14 has a track record behind it, except the one maneuver nobody has ever attempted, the catch itself. The timeline and what it's built on. So when does this actually happen? Based on Shotwell's own public statements and the production data we're tracking, the sequence looks like this. Flight 13, sometime in early July, flying Booster 20 and Ship 40. This one is still a suborbital test designed to confirm the Raptor 3 changes and the broader version 3 architecture before anyone risks a catch attempt. Then Flight 14, targeted for early August. Booster 21 and Ship 41. This is the one. Orbital injection, full mission profile, and the first attempt to catch a returning Starship at the tower. Here's the number that puts this timeline in perspective. The gap between Flight 11 and Flight 12 was 221 days. Over 7 months between launches. If Shotwell's timeline holds, the gap between Flight 13 and Flight 14 will be measured in weeks, not months. Weeks. That's not a small improvement. That's an order of magnitude shift in how fast this program is capable of moving. And it's only possible because of everything we just walked through. 3 ships in parallel production, a launch pad being continuously rechecked, and a booster catch system that's already proven itself at least once before. What happens if it works, and what happens if it doesn't? Let's be honest about both outcomes, because both of them matter. If Ship 41 is caught successfully on the first attempt, it would arguably be one of the fastest paths any rocket company has taken from a first orbital test flight to a fully reusable upper stage. That single moment would mark the point where Starship stops being an experimental program and starts being an operational system, one where ships fly, return, get inspected, and fly again, the same way an airliner does. If it doesn't work on the first try, that's not necessarily the disaster headline writers will try to make it. Look at the booster catch history. SpaceX didn't get that right on the first attempt either. It took multiple tries, multiple data sets, multiple incremental fixes before the chopsticks closed around a booster cleanly. The pattern with this company has consistently been attempt, gather data, adjust, attempt again, succeed. There's no reason to assume the ship catch will be different. Ship 42 is already in the pipeline behind Ship 41, ready to absorb whatever lessons come out of Flight 14. So the real question isn't, will it work on the first try? The real question is, how many attempts will it take, and how fast can the next attempt happen after this one? And based on everything we've just covered, the answer to that second question is faster than anything this industry has ever seen. Zoom out for a second. Why does any of this matter beyond the spectacle of watching a giant steel tube get caught by metal arms? Because a fully reusable upper stage is the missing piece that makes everything else. SpaceX has talked about actually possible. The lunar base, the orbital compute constellation, point-to-point cargo delivery. None of that works economically if every single ship is built once, flown once, and thrown away. The entire business case for those bigger ambitions depends on this one capability. Catch the ship, refly the ship, repeat. That's what makes Flight 14 different from every flight that came before it. It's not just another data point in a test campaign. It's the proof of concept for the foundation everything else gets built on. Ship 41 didn't ask to be the one, but it is. Ship 41 doesn't know if it'll work. Neither do we. Not yet. Like, subscribe, and tell me below. Clean catch on the first try. Thanks for watching the Space Brief.